Well, welcome back, folks. Today we're going to talk about repairing the inner rear fender for the SL125 project. This plastic inner fender fits between the rear wheel and the frame of the bike itself. And it's really it goes vertical. It fits something like this, and it bolts via these four holes to the inner down tubes of the frame, and it's designed clearly to keep road debris and splash away from the air cleaner housing, the rectifier, and the rest of the bike. This was quite dirty when I took it off, so I've washed it in hot soapy water and let it dry. It's in reasonably good condition with two exceptions, and that is this tab you can see here is pretty much broken away. It's all still there, but it's very delicate. And then this tab right here, of course that's where that bolts into the frame, also has a break right there, you can see, I think. So my mission today is to repair those two damage points before I reinstall this back on the bike. The rest of the cover, though I might do a little polishing, is in very good shape, as you can see. These might be available out on eBay. I didn't look, but I think I can pretty easily make this piece serviceable. Now, my intention today is not to do a tutorial or how to repair plastic. There are literally dozens, if not hundreds, of videos on YouTube about plastic repair. And there are many different techniques and processes. You can buy kits that come with either like a soldering iron or a hot air gun. Often they'll have plastic welding rod. That's one of the methods you can use to repair plastic, and I'll come back to that in a second. They're fairly expensive. I don't have one. I've really never needed one. You can get adhesives that are designed for plastic. Some plastics repair easier than others with adhesives. Again, you can use solvent welding, typically something like MEK, methyl ethyl ketone, or acetone can be used to melt certain plastics if they're susceptible to that. And again, heat welding with a soldering gun, etc., etc. I suppose one could even build this up with like an epoxy two-part component, and build it up, file it down, and re-drill it, and reshape the holes. So that can be done. Epoxy tends to be very hard and brittle, though it would probably work in this application. But I'm not going to do any of those basically. What I'm going to do is I'm going to use a soldering gun, and I'm going to melt. Basically, it's a form of welding. I'm going to melt this piece together here on both sides and do the same thing here. This one's a little bit more delicate, so I think I'll start with this one first to develop my technique, and then I'll move on to this one. Once I've got it melted back together so it's not so delicate, what I will probably do then is I'm going to use a slurry. That's what this is. I don't know if you can see it in there or not, but that's actually a slurry right there that I made yesterday. Now, it's real important, depending on your approach and the technique you're going to use, to attempt to identify the type of plastic you're working with, because there are many different types of plastic. I believe this is ABS. And I determine that usually by putting it in water, and if it sinks, because ABS is denser than water, it will sink to the bottom of the container of water. And ABS is so common on these bikes. I'm pretty certain this is an ABS plastic, even though it's not labeled. This is before the days where they would stamp into the component the numbers or letters of the composition of the plastic. And so this one has no letters on it or numbers whatsoever. So pretty confident this is ABS. The way I made this slurry is I took an ABS pipe fitting, this is what's left of it, and I just cut strips of it on my bandsaw yesterday. Put a little bit of acetone in this glass jar. I wish I had a little shallower glass container, but I don't. This is the only one I had that was small. A little too deep for my purpose, but I'll make it work. A little acetone, MEK would work, and then I put the slivers, and I put quite a bit of it in here. Put the slivers from this plastic fitting, immersed it in the acetone overnight, and let it dissolve. And the result is, like I said, a slurry that you can paint on to build up the joints. So those are the two techniques I'm going to use. First, I'm going to use a hot soldering iron to melt that together, and then I'm going to build it up with a slurry, which is really a form of solvent welding, really, for all practical purposes. And then I will probably have to drill it and reshape it in some form back to the original hole, which, by the way, was a little elongated. These holes here and here are not round like these holes are. Got a little bit of a elongation to them, or more of an H shape, but I can finesse that later. I'm not intending again to show all of this. I will show bits and pieces so that you get a flavor for what I'm going to do. Also note, this aesthetically is not going to be the prettiest repair you've ever seen. I don't really care. What I'm after here is really function over form. I'm more concerned about having a robust repair when I'm finished rather than a pretty repair, because this is going to be up inside the frame anyway and you'll never see it. So I want to ensure the integrity of the repair is there rather than worry about making it look nice and pretty. This is relatively thin material here, so that's why I'm going to build it up with this slurry I talked about. And that might take a little bit of time because I'll have to put several coats on both sides, and continue on with reshaping the hole. So that's the gist of what we're going to do today. Let me reset up here a little bit. I'm going to show you how I'm going to go about this welding, and then I'll bring you back. While I have the piece set up in my little portable vise, I realize this might not be the best angle for you, but it's a good angle for me. And again, I'm going to use a soldering iron, and I'm going to weld this seam right here back together on both sides. Now the tool I'm going to use for that is just an old soldering gun. I have a couple of these. This one's dates to at least the early 80s. Still works fine, but it is one of my old ones. I'm not going to use my good soldering gun for this. And here's that piece of PVC piping or fitting that I use to create that slurry, and I just want to make sure that it's up to temperature, so you can see how that works right there. I think it just uses heat to soften the joint. So I'm not going to V this out. I know some people might say, well, gee, why don't you V it out? Well, by doing this with this tool, I'm actually going to duplicate V'ing it out. So just bear with me here. I'm going to let that cool for just a minute because it's very hot right now. My intention here was simply to get the joint back together. This is just the beginning. You might be able to hear the heat unit in the background cycling. For the shop, I have in-floor radiant heat, and there's a boiler on the wall, and that's what you're probably hearing. One thing I didn't mention earlier, that this is just a zip tie, just an everyday common zip tie. I believe this is made out of ABS also, because I did test it and it seems to be ABS based. And what I'm going to try to do is use this as a filler for that seam right there. So I've got the initial fill done. What I'm going to do is flip it over and I'm going to work on the back side. I won't show that just because my head's probably going to get in the way of the camera. And after I've got that complete, we'll come back and talk a little further about where we're at. But I've got this initial weld done. Used a little bit of the zip tie as a filler, as you can see there. And again, another thing I didn't mention, in some of the kits that you can buy, they will use either stainless steel or an aluminum fine screen that you could put over that and embed actually into the plastic using heat like this. This plastic's pretty thin and I don't think that's necessary for what I'm doing. I have used that technique, but I'm not going to use that in this particular instance. So we'll be back in a few minutes. Well, I've got the initial weld complete. It's the one I just showed you, and then this is the one on the inside. Again, I'm not going for appearance right now. I'm just going for structural integrity, so I've got it filled. Now, for all practical purposes, you could probably just file this off or take a Dremel and clean it up, and it'll be good to go. But I'm going to build this up, I think, with that slurry I just talked about, at least try it. I might come back and use this instead, this filler material. I'm thinking I'm going to just paint that slurry on and build this whole section up because it's obviously a weak spot. But before I do that, I'm going to go ahead and repair this, weld this section here on the opposite side, which is going to be a little touchier than this one was. But I want to get this because these pieces are loose. I don't know if you can see that or not. And I don't want to bump them in the process and have everything fall apart. So I'm going to go ahead and do that next. Well, I've got this one. This is the worst of the two built up, as you can see, I think, on both sides. I think what I'm going to do now is take a Dremel and clean this up a little bit and flatten it out on both of these joints. And smooth it down a bit. And then decide what my next step is. Whether I'm going to continue to use this, or I'm going to use a slurry. I might try both. We'll see. Well, it's maybe 5 minutes later, and I used my Dremel with a sanding disc or wheel, as you can see there. Drum. It's a coarse. I tried several different bits, and that seemed to be the one that worked the best. So as you can see, I've smoothed that out a little bit on both sides. And this is the one that was in the worst shape. I think you can see it there. Now, frankly, this could probably be installed pretty much the way it is. You might have to open up, especially this hole a little bit more for the, there's an insert that fits in there steel insert to make it fit right. But beyond that, this probably would be serviceable just like what it is. But I'm going to go ahead now and use the, I think I'm going to try the slurry and see how that works with an old paintbrush, a little paintbrush, and build this up with coats on both sides, and then figure out how to finish it after that. So you can see a little bit of the slurry I've got there. And again, I'm not going to show all of this, but I will show you the basic technique I'm going to use. Just paint it on. And build up that joint. A little shallow right there. I'm going to put a little extra in there. And I'm going to continue all the way around. I'll do both sides of this joint, and then I'll work on the other one. So I've got one coat on both sides of both of the joints that I had to repair. And now what I'll do, I don't know if you can see it there, what I'll do is I'll let that just sit, let the thinner evaporate off, and then leave behind the ABS. And I'll probably put on at least 2, if not 3 or 4 coats while I'm doing it, because I want to build that thickness up. And whether I'll do any finishing when I'm done, such as sanding or filing, I don't know, we'll see when we get there. We're probably 45 minutes later or so, and I now have 3 coats on both sides of the repairs. 3 coats of the slurry I made. I allowed about 5 minutes between coats or so, maybe a little more. And then I put on the next coat. Then I let it sit for another 5 minutes or so. And I took clean acetone in the brush, and I brushed it with clean acetone just to smooth out the surface. And that's what it came out looking like right there. And it is, it's built up plenty thick. I think you can see there. And there. So what I'm going to do now is allow this to sit for 24 hours or so, make sure that slurry can set, and then I'm going to have to come back and open those holes up a little bit. Probably we'll use a Dremel for that, I'm not sure yet. Again, these 2 are elongated versus these 2 that are round. So I'll have to just open those up just a little bit, especially this one, I think. So we'll catch up to this in 24 hours. Well, it's a day later, and the repairs have cured out nice and hard. That plastic is very hard now. I did use my Dremel with that milling bit you can see right there, as well as a couple of little fine files to clean up the holes and open them up a bit to allow for the inserts to fit. So as far as repairs go on these 2 tabs, I'm going to consider this complete. Now I did consider, just trying to flatten it off a little bit, but I don't think it's going to be necessary, frankly. I could have done that with files, sandpaper, perhaps even the milling bit, but I'm not going to bother. This is the hardware that is used to attach this to the bike frame. Everything from here up is new. All of these parts still available from Honda. These bottom 2 pieces are the 2 originals that go into these elongated holes right here, like that. And the original 2 of these I do have. They're right here, and they could have been reused, but they're very rusty, as you can see, and I just basically stripped the rust off them because I wanted to see the condition. And since these were available new, very inexpensively, I just went ahead and ordered these 2 inserts new, but I'm going to reuse these. These are not, these oval-shaped inserts are no longer available from Honda. I'm going to go ahead now and attach this to the bike. I want to get that done obviously before I attach the rear wheel, because then access to this becomes much more difficult. That's going to be it for this video today, folks. That is showing my approach on repairing these damaged tabs. Again, it was not intended literally as a tutorial or how-to, but I did want to give you a flavor of how I did it, as well as discuss the other options one might have if they're trying to repair something similar. We're going to call it quits with this video then. Any issues, questions, thoughts, drop me a note. Otherwise, as usual, thanks for watching.